Hey, good evening folks. My name is Suraj and I will be taking care of your Hadoop sessions. So let's start with our Hadoop class. Now, first of all, let me discuss how are we going to start our classes, how are we going to proceed further in our classes. So every day at around our class timing, let's say 9:30, we'll meet up in Skype and TeamViewer. I'll share the TeamViewer meeting request, meeting ID, and you join the meeting. Okay, and when we start the call, you please put your mic on the mute mode so that there will not be any disturbance in the conversation. Now, when I take up the classes, and if you get any queries, like if you get any sort of doubts, then don't try to speak it up directly, but instead we'll have a chat message box. Okay, we'll have a chat message box in TeamViewer. We'll use that to communicate. If you have any doubts, if you don't understand something, if you want me to repeat something, please type it down there and I'll listen to it. And moreover, we'll just be using Skype only for communication, so please do not try to ping anything on the Skype. I will not be able to see that, I will not be seeing that. So instead of that, we just use the TeamViewer chat option. Now we will not use any sort of PowerPoint presentations here, because I feel using presentation is very dull, and we will have a class which will be more effective than just going through the slides. And I just don't want to give you the corporate training, but it should be somewhat more or less it should be somewhat as better as your online your real class training. And every day what I will do is, like, I'll just create a folder. Let's say new folder 1.introduction to big data and Hadoop. Every day we'll start like this. I'll create a folder, and here I'll put all the discussions what we do today, okay, along with all the materials, all the examples which is needed for today's example. I'll put it here, and we'll also record our sessions as I'm recording this session. And once the class is over, I'll share these sessions to you via Dropbox. Now today we'll start with a very simple, I just want to start with what is a big data and what is Hadoop and why should we go for that. So let me say today's discussion. Okay, now I have also prepared some material here. Let's go up and let's get it down. Copy. Paste. Okay, so this is not the book from internet, this is our own material what I have prepared, and for different topic I'll be sharing this kind of material which contains whatever information you need. So let's just go through this material, unit of data, some sort of details here, and you see there are some links as well. Okay, so if I am discussing something, then I'll also try to provide you from where exactly I have collected these details. Okay, so let's start with our first point, unit of data. Now we all know that in computer there is something called bits, right? So one bit is the smallest unit of computer. Yeah. Now greater than bit we have something called byte. So 1 byte is equal to 8 bits. Okay, greater than bits we have something called, greater than byte we have something called kilobyte. So 1 kilobyte is equal to 1024 bytes. Okay, so we'll just ignore this 24 and let's say 1000 for convenience. Again, above kilobyte we have megabytes is equal to 1000 kilobyte, okay, which is equivalent to 10 to the power 6 bytes. Again we have 1 GB, which is equivalent to 1000 megabytes, which is equivalent to 10 to the power 9 bytes. Again we have 1 terabyte, which is 1000 GB, 10 to the power 12 bytes. Again we have petabytes. So till now, whatever unit we discussed, we already might have come across this, right? Nowadays, whatever computer you buy, whatever laptop you buy, that comes with at least terabytes of hard disk as well. So these are all, we can assume that these are all small data. It can be processed, but the big data, when we say it, generally you can consider these terabytes also as a big data, but anything beyond this you can still consider it as a small data. Okay, so 1 terabyte, and beyond terabyte you have petabytes, PETA bytes. So 1 petabyte is equal to 1000 TB, which goes to 10 to the power 15 bytes. Again, beyond petabytes you have exabyte, 1 EB exabyte equal to 10,000 petabytes, again which goes to 10 to the power 18. Beyond this you have zettabyte, 1 ZB zettabyte, so it is 1000 zettabyte equal to 10 to the power 21. Beyond this you have yottabyte, 1000 ZB is equal to 10 to the power 24 bytes. Okay, beyond this we have zenottabyte, 1 XB equal to 1000 YB equal to 10 to the power 28, 24 plus 3, 27 bytes. Okay, so this is a classification of data. Now till here, till GB, you can say these data are small data. Okay, if somebody says I have 1 GB of text file, that is okay, that is really you can categorize it into small data. But if somebody says I have 1 terabyte of data, then we should definitely think about, we can definitely say it is a big data. Now the question is, why do we need to deal with this big data? What exactly is a big data? Big data is nothing but huge amount of data. Okay, big data is nothing but huge amount of data. And this sort of data gets generated from end users, usually end users. As an example, Facebook clicks, okay, likes, comments. Okay, again let's say sensors. What sort of sensors? Let's say weather forecasting sensors, or let's say traffic sensors, and there are many devices which generates huge amount of data. We'll see that later. Now the question is, why should we deal with big data, and why do we really need that? Okay, so let's take one example. Let me take the example of Google. Okay, now let's assume that I am a non-technical guy. I don't know what is computer, I don't know what is programming, I don't know what is software, I don't know web application. I am a normal, graduate, right? And for me, what is a Google? Basically, Google is a search engine for me, right? And why do I use Google? I use Google to search something like, let's say, 𝗟𝗏𝘁 songs. Okay, let's say Britney Spears songs. Okay, let's say Flipkart mobile phone. Let's say Flipkart Moto G mobile phone. So I use Google to search some data like this. Now Google, I also use Gmail from Google, right, for my mail. Again, I may also use Google Drive for storing some data. Okay, again, I may also use Google Docs to share some data. Again, I may also use Google Map to locate some places. Now I am using these many features, these many facilities provided by Google. Okay, but am I paying any amount to Google? No, we are simply paying 0 rupees. Right? Now the question is, if you are not paying, if I am not paying, then there are many such users who are really not paying anything to Google to use all this data. But how does Google gets benefited from this? That is a big question. Is not it? How does the Google make money if it is providing a lot of services free of cost? How is he making money and how is he surviving in the industry? Now let me take another example. I'll talk about Facebook. As a normal non-technical user, okay, I just use Facebook to chat with my friends. I share my photographs, I update my status, right? I create some albums, I upload some videos, and I get entertainment. Now again the question is, how much money I am paying to Facebook every year? 0. Right? So now the question here is, Google and Facebook are the top 2 companies in IT industry in the world. The most popular top 2 companies are Google and Facebook. Now the question is, how they are getting benefited. Okay, if you take the example of Amazon, if you take the example of Flipkart, they are basically online shopping website and they make the benefit from the customer. They make the benefit from the customer. But Google and Facebook, they don't do. Okay, now the question is, how are they surviving still? So let me talk about what they do, what exactly they do. Google. Okay, let's say you have your email ID. You have your email ID 𝗚𝗏𝘁@gmail.com. Okay, and let's say you logged into Gmail or you logged into Google, and then you started googling for Moto G mobile. You started googling for Moto G mobile. You want to buy a new Moto G mobile. Okay, now when you logged in as 𝗚𝑺.hadoop and you started searching Moto G mobile, okay, the Google will capture your details. The Google will capture your details. Now on that, when you are trying to search Moto G, you started comparing Moto G with Nokia, maybe Lumina. I'm not sure. There is some model called Nokia, Lumina, or Lumia. Okay, so when you started searching for Moto G mobile, you came across some product called Nokia, Lumina, and you started comparing them. Now the Google will also, captures these details, and at the end it will make a query like this: 𝗚𝑺.hadoop@gmail.com. okay, is looking for Moto G, may also like Nokia Lumina, and may also like let's say Samsung Galaxy. Okay, now it will start collecting my details, and similarly it will capture the detail of all the people who are using Google for free. And later what happens? Flipkart, okay, they buy this data. They buy this data from Google. They buy this data from Google, and then they will use this data for their business. So you might have noticed sometime when you log into Flipkart.com, and when you say your email ID is 𝗚𝗏@gmail.hadoop@gmail.com, immediately you may get some sort of recommendation like Moto G for sale at 12% discount. Immediately you may get something like Moto G for sale at 12%. Now you will be surprised, how does this Flipkart guys know that I was looking for Moto G? Or all of a sudden you may get one email into your 𝗚𝑺.hadoop@gmail.com saying that Flipkart some offer, get Moto G at at a discount of 12%. So the question in my mind is, how the Flipkart came to know that I am interested, I was planning to buy a mobile. Okay, so here comes the big thing. Now the Google had captured your data, and it started selling your data to Flipkart. Similarly it will do with Amazon. Similarly it will do with all other business company, and they get a lot of money from that data. Okay, so what I am trying to conclude is, the data which is there in the internet can be used very effectively, okay, to make more business from public, and that is the reason this big data is now a booming technology in the market. Similarly, now let's take one more example on this big data. Let's say we have 1000 ATMs in each state. Okay, let's say we have 1000 ATMs in each state. I'll say State Bank of India, or let's say Citibank ATM in each state. Okay, now if I talk about the whole country, let's say around 20,000 ATMs. Now every day in all these ATMs, a lot of people go and they withdraw some amount. Is not it? So let's assume that, I will take the example of Hyderabad. Let's say Kondapur is a place, let's say High Tech City is a place, let's say Madhapur is a place, let's say Kukatpally is a place, okay, and let's say 𝗥𝗲𝗴𝗃 a place. Okay, now here let's assume we have one ATM each from Citibank. One ATM here, one ATM here, one ATM here, one ATM here, and one ATM here. Now I want to find out which ATM out of these ATMs, okay, has done the maximum transaction in the last 10 years. So the query is last 10 years maximum transaction. So it's very difficult to identify now, because the detail of 10 years, okay, you will have to take the detail of 10 years, and then you need to analyze, you need to write some sort of queries. And if you assume that all these data are stored in a simple text file, then to store the data of 1 year, okay, maybe you will need around 10 terabytes of disk space. Possible. Okay, now for 10 years, to store the 10 years data, you need around 100 terabytes. No, you may not have 100 terabytes of disk space, a single disk space. So here the data is very huge, but you need to process it because your business demands. Okay, so here also what we found is, yes, the data are growing day by day, and we need to find one or other solution to get the to process this data so that we can get a very good result out of it. So let me go with one more example. Let's assume I have a file called employee.txt, and it contains the employee detail of the whole India. Okay, so let's say employee ID, employee name, employee salary, employee age, employee address. So this is basically employee.txt is basically a file, a comma separated file, okay, which contains data in this format: employee ID 1001, employee name Suraj, employee salary 5000, employee age let's say 26, employee address let's say Kolhapur, similarly 1002, Suman 10,000, 27, high-tech city. Okay. Similarly, let's assume that you have the whole detail of all the employees of India. Now, the first thing, what would be the size of this file? The size of this file may go across some petabytes. Let's say 10 petabytes, or let me not take a big number, let's say 300 terabytes. Okay, now I want to find out how many employees are there under the age of 30. How many employees we have, okay, who are below 30 years of age. So in order to process this data, in order to find out this number, you need to check all the records present in this txt file. Okay, so I'm just giving you the example of txt file. Actually in the real time you may not be storing the data in txt file, but my concern is I just want to make you understand the power of big data. Why should we analyze big data? Why should we process big data, and how should we process them? Now if I talk about Java, since I'm a Java programmer, I know how to write a Java program. So if you talk about Java program, then you may need to write program like this: public class count employee under 30. This is my class name. So public static void main string args now the first line would be point to this file. Okay, I'll use scanner, let's say, because it is a very easy approach. Scanner scan is equal to new scanner of system, not system, new file of the file name. Let's say the file is present in this location, D drive / employee.txt. I'm just giving you an example. Okay, don't take it so seriously. D:employee.txt. Okay, we got we pointed to a file. Now the next would be read the file line by line. So while scan.hasNext, if yes, then it goes to the next line. Now string line is equal to scan.next. So when you say string line equal to scan.next, it will give you this whole line one by one. First time this line, second time this line. Okay, so you will get this line in your line object. Next, now you need to get access to this 26, because my intention is find out all the employees whose age is less than 30. So you split the data, you split this line. So I'll say string array of data is equal to line dot split of semicolon, sorry, comma. So I'll split the data, I'll split this line and store it on the array. Okay, now when you say split of comma, 1 2 3 4 5, all these 5 strings will be stored here. Okay, data 0 will contain this, data 1 will contain this, data 2 will contain this, data 3 will contain this, data 4 will contain this. Now the objective would be to get access to this 0 1 2 3. So I can say int is equal to data of 3, 0 1 2 3, data of 3, and this is basically a string, so you need to convert it into integer dot parse int of. Okay, now you will get the age. After this you check whether the age is greater than 30 or not. If age is less than 30, count plus plus. So you define one counter here, int count is equal to 0, count plus plus. Okay, so your counter will be incremented. Now once this while loop gets over, okay, after that you try to check the value of count, system.out.println count. So this will actually give you the total number of employees whose age is less than 30. So I have just given a very small requirement here. Now the problem what we will get is, the first problem, storing that employee.txt. Okay, that is the first problem, because the size of this file will exceed terabyte, let's say 300 terabytes. Okay, and moreover in the real time when I say employee detail, these are not the only details. You will get a lot of details of employee ID, employee name, employee salary, employee address, employee mobile number, employee company's name, employee's experience, employee this, employee that. So the data will be huge, and altogether if you assume that the data goes to 300 terabytes, you will not find a single hard disk to store all this data. This is the problem number 1. Next problem, even though you become successful to store that data in one or other way, then processing the data using this kind of a single standalone core Java program will not be sufficient, because if you run this program, then I believe you will get the result. I'll tell you when you will get the result. 300 terabytes, right? So we have 3 terabytes of data. Now to process 4 GB, it took me 12 minutes in a single system. That means 1 GB will take 3 minutes. Okay, that means 1000 GB will take 3000 minutes. 1000 GB means 1 terabyte. So 300 terabytes will take you 3000 into 300 minutes. Okay, by hour. If you do, let's say Control R, CALC 3000 into 300. This is minute. By hour, if you do by 60, this will be hour. This many hours. By 24 you do. So it will take 625 days by 365. So 1.7 years. Are you getting my point? So the conclusion is if the data is huge and if you write a single Java program, it will take 1.7 years. Now what will be the biggest problem? After 1.7, let's say you started this program, you started executing this program today. Okay, so it will give you result after 1.7 years. And after in between this 1.7 years, you may have lot of other employees who are employed, lot of people who are employed. That means new employees are also added, right? And after 1.7 years, the total count, whatever you will get, that is not the correct accurate count. Now the thing is, we just need to process this data, but writing a simple traditional Java program will not help you out. So this is the reason why we are looking for something which can work on big data. Okay, and Hadoop is one of the solutions. So if somebody asks what is a big data is nothing but huge set of data, huge amount of data, where we may find it difficult to store them and process them using a single system. Okay, now what are the prerequisites to learn Hadoop? So I'll say Hadoop is a Java component. Okay, that means you must have a knowledge on Java, at least the basic knowledge. So I expect you guys to have a knowledge on core Java, and in the core Java, what all do you need? OOPS concept, which contains inheritance, basic inheritance, interfaces, okay, methods, and some sort of exception handling. That's all. Do you need multi-threading technique? Not needed. Multi-threads, socket programming, swing, AWT, RMI, JDBC are not needed. Okay, do I need to learn J2EE? Do I need to have knowledge on J2EE? Not at all. No servlets, GSPs, no Spring, Hibernate, services. Okay, that means if you are good at this, then you can learn Hadoop. Now let's talk about the data again. Okay, how big is this data? So I'll just go through my example notes here. When somebody says 1 byte means 0 and 1. That's all. Sorry, 1 bit means 0 and 1. But if somebody talks about 1 byte means usually a single character. Okay. Similarly, when somebody talks about 1 kilobyte, let's say somebody said I have 1 kilobyte of data. So you can just assume, okay, you just have a very small short story. Now, if somebody says I have 1 MB of data, that is equivalent to 1 noble. Okay. Similarly, if somebody says I have 1 GB of data, that means you can assume a pickup truck filled up with paper, and in all the paper you have written something. Similarly, 1 terabyte means, let's assume 50,000 trees were cut down and paper were produced out of it, and all the paper were used for writing some data. 2 petabytes, all US academic research libraries. 5 exabyte of data is equivalent to all the words ever spoken by human being on earth. So I got all this information from this link. You can go and get more grips on this. Next, let's talk about the companies who are using big data. Okay, AT&T, they use big data. Google, they use big data. BitTorrent, they use big data. Even when we talk about this movie Avatar, okay, when it was created on 2009, and they say that the video that was captured to create this movie Avatar, and they required around 1 petabyte of space to store that high clarity and 3D videos, and to process them they took around 1 petabytes. They consumed around 1 petabytes of local storage. Some of the interesting fact: in Google, every second 20 lakhs people write some query. Every second 20 lakhs people searches in the Google. Every minute in the Facebook, 34,000 likes. Customers are spending around 3 lakh US dollar on shopping per minute. In Twitter, you will find around 1 lakh tweets per minute, and in YouTube you will see around 600 new videos are uploaded every minute. So this is the example of big data. Okay, this is the example of big data. Now you will get a lot of companies using big data. Not only Google and Yahoo, even a small companies also uses big data to process something very to process some data. Like all the banks are also nowadays working in big data. If I give you the example of bank, let me talk about this: Visa, Mastercards, Maestro card. Okay, Amway, you might have heard of this. Amways, even HP, IBM, and all other companies are using big data. Next, now let's say after learning this big data, what is the opportunity that I'll get a job? Okay, big data positions. I'll open my email ID. This is my mail ID. Now just check it out. Great opening for big data Hadoop developer. This was yesterday's mail. This is also a big data job on the same day. this is for Hadoop admin on 19th, this is on 17th, this is on 16th, this is on 15th, this is on 15th, 14th. So you can see almost every day there is one or other mail from one or other company saying that we are looking for big data experts. Now, next thing, why so craze for big data? Why do we have so craze for big data? The reason is we don't have sufficient resource. Okay, data is growing very rapidly day by day. Okay, the reason for the big data, the reason for huge requirement for big data professional is very simple. We don't have sufficient resource. We need more and more resource because the data is growing very rapidly day by day, and our existing resource are not sufficient to fulfill that demand. Next is, what is the future of big data? The big data market will go down tomorrow if people stop using Facebook, stop using smartphones, stop using online systems, etc. Now the question is, will the people stop? Answer is no. That means the future of big data is always good in tomorrow's market. Okay, now what are we going to learn in our big data, in our Hadoop classes? So what all I'm going to teach you in this Hadoop sessions. So I'll just go to the previous classes, whatever I covered. Let me just give you a glimpse of that. F drive. Okay, so this is all what I taught in my previous session, in my previous Hadoop classes. So we discussed about MapReduce, Hive, Scoop, Pig, HBase as well as 𝗚𝗎. I did not download the 𝗚𝗎 folder here. So for the MapReduce, we took around 37 classes, 37 complete classes on MapReduce, and each class contains a video and whatever discussions, and if any materials and examples are available, we will put that on the video itself. Okay, let's go to something like word count example. The very first example we started on class 16th. So till that time, a strong foundation on MapReduce. Let's go to Eclipse. Okay, right click on this and say extract to this. Now you check it out here. Here some sample program is there, some plugins which we used, some discussion videos, some images and recordings. You go to any example, the last example, extract this, Okay, so the recorded video, this is the libraries as well as program, I believe. And here we have a sample program. So all the classes whatever we take will be recorded on spot, and we will send you that after the class. Okay, so we had around 37 classes only on MapReduce, because this is very important. 37 plus Hive is around 12. 37 plus 12 goes to 49, plus 5 54, plus 9 63, plus 5 69, plus 2 more classes, so 70. So I'll say to complete Hadoop in a very good manner, you need at least 70 classes. 70 classes into 1.5 hours. So that goes to around 100 hours of classes. Okay, let's come back to our example. Now let me talk about some processing capability of the company. For example, Google processes around 20 petabytes of data per day. Okay, petabytes means next to your terabytes. 20 into 1000 terabytes of data per day. Facebook processes 2.5 of user data and 15 terabytes of system data. So what is the meaning of user data? Whatever message you do, whatever chatting you do, whatever like you make, all those are user data. eBay processes around 6.5 petabytes of data plus 50 terabytes of data per day. So these are basically the processing capacity of the companies like Google, Facebook and eBay. And Yahoo has got the biggest cluster, the Hadoop cluster in the whole world. If I can show you the diagram here somewhere. Okay, now you look into this system. This is basically Yahoo system, which contains 4,000 computers. These are all called racks. 1, 2, 3, 4. So we have a lot of racks, and in each rack there are some small computers. Okay, so these computers all together makes 4,000 node Hadoop cluster. Alright, now let's talk about example datasets. So as we are going to learn Hadoop, which is nothing but a framework to deal with big data sets, big data. Okay, now the question is, while practicing the examples, are we going to just write a simple hello world kind of examples, or are we also going to work with some sort of use large data? So we have a lot of options available. We can download varieties of data sets from internet, and we will use that for our learning. For example, here I have included some of the important data sets, some of the important link from where you can collect the data sets. What is data set? Data set is nothing but a file which contains data. Okay, so if you want to really test your program with, let's say 10,000 records, 20,000 records, 50,000 records, 1 lakh records, 1 million records, so we can get those records, we can get those data free of cost from internet, and we can use it for our Hadoop experiments. Let's go up. Okay, so this is a company, this is a link like 𝗙𝗏𝘁'𝘀, very popular, and it is given by CSE. Okay, now somewhere you will get data marketplace. Oops, looks it is down now. No problem. Okay, I'll just Google it out. google.com million songs dataset. Okay. A million song dataset is freely available collection of audio features and metadata for a million songs. That means you check it out. To start your own experiment, you can download the entire dataset of 280 GBs. So if you are interested, you can download the dataset of 280 GB. Okay, and then you write some sort of Hadoop programming and run your programming on this 280 GB of data. Okay, so you can still get a lot of data from internet. We will see that when we are going through courses for different topic, for different example. We will try to experiment with the different sort of data sets, so that you will get more and more practice. Now even you can get, if you want only, you can get only 1% of data set, which will give you around 1.8 GB of text data. Okay, so if you want, you can even work with only 2 GB instead of downloading 280 GBs. So you will get a lot of support from internet. You can go and access some public data. You can even get Facebook data. I'll try to do that. You can even get Twitter data and run some sort of program on those datas. So here is what I have listed, some of the popular data sets website from where you can collect huge amount of data. Now let's start with Hadoop. Now as promised, we are not going to go through slides, read the slides, but this document will be our helper document, which will help us to always go in a particular angle, in a particular direction, so that you don't miss anything. So I just refer this document while teaching you. I'll create more and more document and we'll go in this way. Now Hadoop is basically, as I said, a Java framework to process, to store and process huge amount of data. Huge means no limitation. Okay, it is not limited. It is limited to your hardware only, but the more hardware you add, the more powerful it becomes. Next, it can be used for batch processing, but not for online processing. We'll discuss this later. Next, it believes on working with commodity hardware rather than expensive computers. Okay, so what do you mean by this commodity hardware? It is nothing but a daily usage PC. Okay, that means if you want to practice Hadoop, if you want to set up some Hadoop system, the Hadoop does not demand you to go and buy a very high and expensive machines. Hadoop says it is up to you. You can still continue with your daily usage PCs. Okay, unlike some other servers, Hadoop does not require, it does not demand you to buy any expensive software, any expensive hardware as well as software. It just tells you to buy ordinary system, buy more ordinary system and get your work done. Hadoop is free. This is the main advantage of Hadoop. Being able to process petabytes of data, huge volume of data, still Hadoop will not charge you anything to use this feature. Okay, so Hadoop is under Apache and you don't need to pay anything if you're using Hadoop. Now let's start with a story, a very simple story, a very old story. There was a farmer, okay, and he had let's say one small piece of land, okay. After 2 years, one piece of land and one ox as well, okay, and he was using this ox to do this farming in the land. After 2 years, he got 2 more pieces of land, okay, but he had only one ox, and this ox used to get tired after working in all these 3 pieces of land, okay. And the farmer found that day by day the efficiency of this ox is decreasing, because earlier he had to work only on one piece of land, now he has to work on another 2 pieces of land, okay. So there was 2 options with this farmer. One is give more protein food, okay, dieting food, like I mean to say more powerful food to grow the ox bigger and stronger, okay. Another approach would be buy another 2 ox for the extra field. Now the question is, which one will you choose if you were that farmer? Okay, see, if you buy 2 different ox, it will cost you more. If you give more food and more protein, it will not cost you more, okay. But if you buy more protein food and if you feed to that ox, there is no guarantee that the ox will perform significantly very much better. So if I would be the farmer, then I'll definitely choose this. I'll buy 2 more oxes, so that the work will be distributed now and there will not be a burden on a single ox. So Hadoop also follows the same principle. Hadoop says, don't buy expensive hard disk for me, expensive machine for me. Day-to-day machine is enough. But there may be a problem with this day-to-day machine. When you are dealing with a huge volume of data, when you are processing huge volume of data, few systems may fail, few systems may crash, few systems may go down, right? And here you have to deal with this failure recovery as well. But Hadoop will take care of failure recovery as well. Okay, so you can add n number of hardwares, small hardwares, and Hadoop will take care if any failure comes in the middle. We will see that later. How does it do that? Now let me talk something about scalability. Okay. Now if I talk about scalability, there are 2 types of scalability. One is horizontal, another one is vertical. Let's assume you have a system. Let's assume this is your system and you are just processing the data of 100 GB. GB of data for processing, and you have a system which has got the below configuration. The configuration is let's say 2 GB RAM, okay, 320 hard disk, 2 processors. After a few months, your data became huge and it became around, let's say, 350 GB. Okay? After a few months, your data grew much bigger and it became 350 GB. At that time, this hard disk is not sufficient, and you may go and improve. You may go and you may have to replace your hard disk with, let's say, 750 MB. Okay, and you felt that the processor is also not enough. You again added 2 more processors. After that, again after a few months, let's say your data again grew to 700 GB. Okay, sorry, this is GB. And at that time, again you may feel that the 750 GB is not enough. And what you did, you replaced that 750 and you put a hard disk of 1 terabyte. Okay, and at the same time you plan to increase your RAM to 8 GB as well, and you also added more 2 processors. So this is called as vertical scaling, because in this approach the same system is being constantly improvised. We added a lot of resources in that. It is similar to giving protein food to the ox. We call it vertical scaling. Okay, but in case of horizontal scaling, what we will do, let's assume we have the same set of configured system, 2 GB RAM, 320 hard disk, 2 processors. Okay, earlier I had only 350 GB of data. I used this system to process. Now when I got more data, what we will do is I just replicate this. I'll get one more system of the same configuration. I'll get the system of same configuration. Now the total capacity became 4 GB of RAM, 640 GB of hard disk. 640, it is not sufficient. 350, okay, so 100 GB to 350, it will be able to process 4 processors. Later when I get more data, 700 GB, and if this is not sufficient, I'll add one more. Okay, again later if I get one more requirement, I'll add one more. So this is called as horizontal scaling. This is called as horizontal scaling, because in case of horizontal scaling, you will not face the problem of limitations, hardware limitations. In case of your vertical scaling, okay, there will be a point where you will come across the hardware limitations and you will not be able to add more RAMs, more hard disk or more processor. But in case of horizontal scaling, it is your investment. If you have more money, go and buy one more set of a box and add it to your cluster. Clear on this? Now Hadoop basically follows this approach completely. Okay, and it says you want to process big data, huge amount of data, not to worry, just give me a lot of small computers. Okay, and I will take care of distributing the data among these nodes, among this worker, and this worker will work as per your instruction. The programmer writes. Okay, and finally the data will be collected and it will be given to the programmer, it will be given to the end user. Okay, so Hadoop is basically used to process huge amount of data, and they follow the concept of master slave. They follow the concept of master slave, which says there will be one computer out of this 4. There will be one computer which will act as a master, and all other computer will act as a slave. Master will do nothing, but it will just monitor the failure, it will just give instruction, it will get the work done, it will collect the result, and it will give the result to the end user. Master is not going to perform any operations apart from this, but the workers are the actual guys who will actually work hard on your data. And how to work hard on the data, what to do, what not to do, that will be defined by your programmer. Okay, so in Hadoop we are going to learn something called MapReduce. It is basically a programming model using which you will be writing some sort of program, and your Hadoop will behave according to your program. Okay, so you'll get more clarity on what is MapReduce, how to write it when we start with the program. Now let me talk about what else we are going to learn, how are we going to learn in our online classes. So I believe as I said, we will be working with various data sets, and we will try to learn how to install Linux. Okay, we will install Linux on virtual machine. And then we will set up our own single node cluster. In that Linux box, we will install Hadoop. Okay, and later we will also install it on multi-node cluster. We will also install, what we will do is we will take 2-3 Linux boxes, we will install Hadoop in all this, and finally we will create a cluster out of it. Next, we will work with Cloudera. Okay, if needed, I'll also show you with Hortonworks. Okay, and it will be followed by all the examples. Later, in this Hadoop machine, we'll also start installing Pig, Hive, Scoop, etc. So we will see how to manually configure, what are the configuration we need to take care. We will do a complete setup on a single node cluster. We will do the setup on multi-node cluster. We will work on Cloudera machines. We will work on Hortonworks machines as well. Now let's stop for the day, and thank you for watching this. We'll continue tomorrow at the same time.